Hello everyone, welcome to this channel. So today I'm going to now we are at a part 4. In the previous video I have covered how machine learning works, how to get started with the programming using neural networks. The next step is to apply this concept to computer vision, where we'll have a model learn how to recognize a content in pictures. In previous videos we see what is NLP. So NLP is nothing but if computer learn to read our text is called natural language processing. In the same way, if computer learn to how to read our images, as we call it as computer vision. So in this chapter we are going to see the popular data set of clothing items. So I'm going to use some popular data sets from Keras. So for an example, take this image. There are a number of different clothing items out here. So you can recognize them. You can understand this is shirt, this is pants, this is shoes, this is bag. But how could we explain this to somebody who has never seen clothing? How about a shoe? There are two shoes in this image. How could you describe this to somebody? So we can apply this computer vision technique so that the machine can learn the data from these images. So how you learn to recognize all these items? By seeing a lot of different images and gaining experience. That's how human learn to understand the images. In the same way, the computer can learn this data from different methods and gaining experience. So later on, when you give some new images to computers, it will tell you this is shirt or this pant. So based upon the probability that output will the computer will learn and recognize those images. So like I mentioned, I'm going to use the famous Fashion MNIST data. It's a famous MNIST dataset, which means Modified National Institute of Standard and Technology database. From the database, we are going to use those datasets for our trainings. Basically, the datasets contains 10 different kind of images. I'll show you what are the images. If you can see here, these are the different kind of images that are available in the datasets, like pant, shoe, like pant, trouser, t-shirts. So these are different kind of images. Basically, we have 10 labels are available in these images. Also, the dataset total images of 17,000 images are available in the datasets with a scale of 28 bar 28. That's the grayscale. Basically, each image contains gray of between 0 to 255. So that is how we can calculate the images. So here size is 25 by 25. Also the grayscales we call it as between 0 to 250. Fine. So here each picture consists of a certain number of pixels. The values between 0 and 255. If you see, this is a shoes. As an example, I am showing here. So if you see, this is 25 by 25. Length is 25, height is 25. So in this image, each pixel contains between the ratio of 0 to 255. Suppose if you see it's pure white, it means it's a 0. If it is a gray, means it's between like 45 or 50, but it's always going to be between 0 to 255. If it is a full of black, it might be 100 or between 155 to 2. So this is how we can calculate all the images between the grayscale of 0 and 255. In my previous chapter, I have explained the simple model of applying a neural network. There, we are we found that relationship between x and y. So basically, we have x input and we are going to get the y output in my previous video. But here, our y is going to be between 10 labels. It means 0 to 9. That is our output y. Input is again it's going to be 25 into 25, which is going to 784 values. That is our input. So our input is 784 values and our output is going to be between 0 to 9. How it's going to be 784 values, which means each image contains 28 by 28 pixels, so which means 28 into 28 784 values. That is our total input. So like I mentioned, given that we have 784 x values per image and our y is going to be 0 and 9. Now we know how many of our inputs that we are going to give and what are the outputs that we are going to get. So our input is going to be 784 values and our output is going to be between 0 and 9. Now let us build our programming uh, to build a model in order to find that images from the training data. Let's explore how our code is going to be. So here I'm going, as I mentioned, we are going to use TensorFlow, and I'm going to use this Keras dataset for Fashion MNIST. This is an API that we are going to call. So Keras has a number of built-in datasets so that we can access by using the single line of code like this. So now I am going to see tf.keras dataset dot fashion underscore MNIST. So which means I'm going to call this dataset. Let us execute this code. So now we have got a data. The data set is getting downloaded in the data variable. Now we are going to divide the training data sets and testing data sets. For that, we have to use this code. So here, if you see training images, it's training labels, test images, and test labels. If I execute this one, so now the data has been saved between these two. So our next line of code is we are going to divide these training images at 20 by 20, 255, which means the Python allows us to do operation across this entire array. Recall in our previous, sample, we have used a single input, its value is X. So there we don't do this kind of method. Why? Because it's basically we call it normalization. If we divide by 255 by 255, 255 value, the number between 0 and instead, it will comes between this value. This process we call it as normalizing the image. Basically, if you apply the normalizations, neural network works better. But if your input is a simple value, then this kind of normalization is not required. But here we have input like 255 and 255. That is why we are applying this normalization technique. The next step is we are going to create a model. So here, if again I am going to use this Keras sequential one, and if you see here Keras the direct flatten, which means the flatten normally used to convert the two-dimensional array into single dimension. That's why I'm using this flatten here because our input is 2D, so we need to convert those values into single dimension. That's why I used flatten here layer, and next one is dense. So dense means we have to mention how many neurons that you're going to use. In previous video, I have used single neurons, but here I am going to use 128 neurons. So it's like a hidden layer. It's going to be hidden layer. So there'll be no process. There'll be no definition. We have to use 128. It's completely random number. You can use whatever neurons that you want. But basically, if you used minimum neurons, it will take less time for training. At the same time, if you used more number of neurons, it might take more time, or it might be more complex become. So that is the reason here I am using 120 neuron because our input going to be 28 by 28. So basically now I am using only 128. It's completely arbitrary value. There is no fixed rule for number of neurons to use. But at the same time, if you use more neurons, it would lead to neural network that is great to recognize the training data, but not so good at recognize data. Sometimes, there is a concept called overfitting. If you have used more neurons, sometimes the data might go overfitting. You don't get the expected output when it comes to in the inference. Again, if you see here, I have used activate function as a ReLU, which is nothing but a rectified linear unit. The concept is a simple function that just returns a value if it is greater than 0. If the value of loss is going to be greater than 0, it's returned as 0 as an output. We don't want negative values being passed to the next layer. So it's impact our functions. So instead of, that's why we use this simple the activate layer ReLU. The final one is that another tens layer is called output layer. So basically we are going to get output as a 10 between 0 to 9. This has a 10 neuron because of we have 10 classes. So our job is to determine which one has highest value. That is the output we are going to get. For an example, the output is going to be between 0 to 9. So whichever output is higher, so we have to take that as an output. So the next line of code is we are going to compile the model. So again, if you see here, we am using the losses sparse categorical cross entropy. In previous last program, we have used different kind of loss functions, but here I'm going to use category, which means because our here the problem is it's going to be categorical because our item of clothing will belong to between 1 of 10 of categories. So that is the primary reason we are using the sparse categorical cross entropy. Again, not choosing that loss function is an art because there will be no specific loss functions for each model. It's always going to be changed. It's up to us to use these loss functions, appropriate loss functions for our model. Now, if you see, now we have created a model and we have compiled that one, and we have got training images and test images. Now we need to create a training by using the training images. Now we have used save this training images in the training images variable. So if you see here, model.fit training images epoch we can give 10 just for this program. So I'm going to training this one. So if you see in first one, I got 70% accuracy, next 75 and 78. Keep on increasing. For each epoch, it's increasing the accuracy 80%, 81, 82, 80. If you see, now the final one is completed. We got 82% accuracy. Our loss function is 0.49. So now our model is ready for the prediction. So now we are going to predict that our text images. Now if you see, it's got predicted. So all the predicted values have been stored in the under classification. So now we are going to see the first one. If you see here, this all the which one is greater? 0.7 is 0.76 is greater. So which means our label is here. It is 9. It might be 9. Let us see the label. Let us print the label and then see the output. So if you see here, it's a 9. Accurately, it's got predicted. Let us change this one and then we'll see 4. If you see here, here its higher value is 0, 1, 2, 3, 4, 5, 6, 7. So 8 is higher. So let us see the label whether it's got predicted accurately. 6, 1, 2, 3, 4, 5, 6. See, it's accurately. So 8.4 is it is exactly predicted output. So that's it, guys. You can try different values for yourself. In the different value, in the sense, you may try different epochs. Also, you can try with different dense neurons as an input. Here I have given 120. Maybe you can try with different neurons. Maybe you can get a different kind of accuracy. Also, output also you can get as a different. So as I mentioned here, I got only 82% of accuracy, which means some labels it might predict might wrong. So if you use different values in the epoch or in the dense layer, it might the accuracy might go higher. Hope you guys liked this episode. Just put your comments in the comment section. I'll try to reply for that. I'll see you in the next session. Thank you all.